Hello everyone, welcome back to the channel. I am Nikhil Kumar. Today we are going to start very interesting series, that is Linux for DevOps Engineer. Before you learn Docker, Kubernetes or CI/CD, there is one foundational skill that decides whether DevOps feels easy or confusing, and that skill is Linux. Almost everything inside Kubernetes, whether it's pods, containers, networking or storage, is just a Linux feature working together underneath. So if you understand Linux deeply, DevOps stops looking like magic and it becomes logical, predictable and fun. In this playlist, I will take you from absolute basics to the internal concepts of Linux that power containers and Kubernetes. So let's begin. So now let's start from the foundation, because once you see how Kubernetes map to Linux, the entire system starts making sense. Kubernetes is not magic. It's simply an automation on top of Linux. So let's connect Kubernetes component to Linux one by one. So when a pod is isolated from another pod, that's Linux namespaces behind the scenes. When a pod is restricted to a certain CPU and memory, that's Linux Cgroups doing the enforcement. When a pod talks to services and nodes over the cluster network, the traffic moves through the Linux network stack. And when we attach a PVC or a host path volume, that data sits on Linux file system like ext4, XFS or LVM. Even Docker, Containerd or Cryo are not special engines. They are just tools that talk to the Linux kernel. Once you understand Linux, Kubernetes stops looking complicated. It starts to feel logical. Now let's break down the building blocks Kubernetes uses behind the scene. First is namespaces. A pod behaves like it lives in its own universe, its own processes, its own host name, its own network, and its own file system. But that isn't Kubernetes magic. It's Linux namespaces working behind the scene. First is PID namespace. Every pod sees only its own process IDs. It can't see processes from the host or the other pods. Next, UTS namespace. This gives the pods its own host name, so it feels like a separate machine even though it isn't. Then mount namespace. It lets a pod see a different file system view from the host, and that's how containers get their own root file system. And finally, the network namespace. Each pod gets its own network stack, its own interfaces, its own IP. So container is not a tiny VM. It's just a regular Linux process placed inside namespaces with boundaries around it. So once namespaces make sense, the mystery around pod disappears. Isolation is one part of the puzzle, but what if a pod starts using too much CPU or memory? Who controls that? That's where Cgroups enter the picture. Cgroups or control groups are the feature in Linux responsible for limiting how much CPU or memory a pod can use. So when you define a resource request or limits in the pod definition file, Kubernetes simply tells the kernel, apply Cgroups and enforce this. So if a pod gets out of memory killed, it's not Kubernetes deciding. It's the Linux kernel killing it for crossing limits. So namespaces isolates, Cgroups enforce limits, but something has to apply these rules, start processes and manage images. That's where container runtimes comes in. And this is where one of the biggest misconceptions begins. Most people believe Docker is creating containers, but it's not. Docker, Containerd or Cryo are just runtimes. They are the tools that prepare and launch containers by talking to a Linux kernel. They start a normal Linux processes, apply namespaces, apply Cgroups, and attach a layer file system using overlayfs. So now we know what a container really is. A Linux process isolated by namespaces and controlled by Cgroups. But containers don't run alone. They need to talk to the other pods, to services, and to the outside world. Which brings us to the next question. Kubernetes doesn't create its own networking. It orchestrates what Linux already provides. So every pod gets its own virtual Ethernet interface. And that interface connects to a Linux bridge on the node. And from there, routing and the service handled by IP table or eBPF rules. Here, tools like IP-link, IP-route, bridge, and IP tables are the real packet movers in a cluster. Kubernetes just coordinates, and Linux does the heavy lifting here. Just like networking, Kubernetes storage also rides on the top of Linux only. A persistent volume is never abstracted. It always maps to a Linux storage like ext4, XFS, block devices, LVM or the mount points. If you see a permission denied on a PV, you are troubleshooting Linux, not Kubernetes. Understanding UID, GID, mount option and the file permission is a Kubernetes skill, even though it's just Linux. Now let's zoom out to the control center of a node, that is Kubelet and the system D. Kubelet, Containerd, CNA plugins, all of them run as a systemd service. When something breaks in a node, the first investigation is usually checking the status of the Kubelet service or the Containerd service using the systemctl commands. Or if we want to check the logs for that, we need to use a journalctl. Most nodes issues are not Kubernetes bugs, they are Linux service failures underneath. So if we fix the services, so the node automatically got fixed. Now we have seen every layer piece by piece. Let's zoom out and look at the full picture. Every pod is a Linux process running in namespaces and Cgroups. Every network path is Linux routing, interfaces or the IP tables. Every persistent volume is a Linux storage and permissions. And every node is a systemd services keeping everything alive. Behind every pod, every service and every volume, there is a Linux doing the work. Kubernetes simply brings it all together. And when you finally understand Linux deeply, DevOps start becoming clear, predictable and even fun to work with. And that brings us to the end of video 1. Now you understand why Linux is essential for DevOps and Kubernetes. In the next video, we will start with the Linux basics that every DevOps engineers must know. So if you found this helpful, hit like, share it with your friends and subscribe for more content like this and enable the notification so you don't miss the notification for the video 2. Thanks for watching. I will see you in the next one.